Hi guys, my name is Tepo. On this tutorial, I want to show you how to model a stage in a turbo machinery. A stage would be a pair of a stator blade with a rotor blade. If you didn't watch my first video, I would encourage you to watch that video, which introduces this thing called periodic boundary conditions. Um, Once you understand how the periodic boundary conditions work, I've pretty much used the same concepts in just modeling one blade instead of modeling the whole row of blades. So I'm just going to model one stator blade and one rotor blade and pair them together. I've seen a lot of questions about this on the CFD forums, and people always confused. How do you get this together? How do I show this? And that's why I want to show you guys how to do this. It's quite easy, and you'll be able to follow it quite easily. So what I have already done is I have created my mesh for the stator blade, and I've created my mesh for the rotor blade. Let me show you quickly here on my where's the okay. Got her documents, simulation, YouTube tutorials. Yeah, right here. So I have two meshes, right? Two cases. So what I did is I went from the mesh, I opened Fluent with the two meshes to create the two cases. I did a bit of pre-processing on the two cases and save the case, right? And then I go in and I open a new Fluent screen. I start with my importing my first case. You can start with any one of those. I start maybe with the rotor. I'm going to start with the rotor, import the rotor. It's YouTube tutorials, import the rotor, right? You could import the rotor and the data if already had some data that run a bit of simulation. You had the data and want. You can just import the case as well, which is what I've done here. I hadn't run anything, so I don't have any data except the setup data. So this is my rotor blade, right? So what I want to do is to shift it, because when I import the other one, it's gonna come and be land at the same place. Pretty much the origin, I mean the location in the coordinate system, they sort of coincide with the other one. So I start by transforming this by translation. So I'm just gonna translate it here by maybe just roughly 0.6 meters. Say translate. So what is done is it has shifted it to the right. If I could show you my coordinate system, you'll see that my coordinates are actually changed. The coordinates for these things have actually changed. So this thing is actually moved to the right. And then I load the second one. So the way I load it is by appending it. So what I want to do is I want to have both of them sitting here together and data flowing from one model to another model, right? So I use append, and then I append my stator case, right? Warns me here about renaming and things being renamed. And so when I do that, and I didn't show you this before. Before you had only this zone here called blade, right? Now you have two blades. The other blade is actually where my stator is, right? So everything is sort of doubled up. What I would normally do is to rename all these things properly. For the rotor, I would start with RT, so I'll have RT blade, blah blah, and then for the stator, I'll start with ST. I can refresh here. You see, it says it's out of date. So if I refresh, I should be able to see a new display. You see, Now I have a new display. Now my new display has both. It has my stator, which is here, and it has my rotor, which is here. So my intention is to have the data flowing from the stator. So typically what we would have here in this simulation is my flow will go from here. So I'll have my fluid flowing through this, coming through this boundary here, into this boundary, this one here. So these two boundaries that are called interface zones, I'm going to link them together so that whatever comes out from here actually goes to here, right? And then it will exit here. So the way to do that is to use what is called mixing planes, which is here, which is what I wanted to show you guys. I know I've seen people struggling to put this together, so I just wanted to show you how to put them together. But the most important part of it is really this thing called mixing planes, which allows you to set up the physics. So to do the mixing planes, you click on mixing planes and you will see it here. So the way it works is you need to have these boundaries here as pressure boundaries. So this should be, for example, if my flow is going to come this way and exit here. So this will be my outlet, but it should be a pressure outlet boundary. So I go to this one, which is here. I'm going to change it from wall, change it to pressure outlet. So I say pressure outlet. I put in the boundary conditions. There's no need to put the boundary conditions because once you link them together, that thing is really just to link these two things. Data will be flowing pretty much. Flow will come from here and then leave here. So this will be your outlet and this will be your inlet. These are more like interface or intermediary zones. This one says it's a pressure inlet, which is what we want, so that's good. So I have my pressure inlet, I have my pressure outlet. This one says pressure outlet, which is the other boundary. This one says wall. This is supposed to be, maybe these two is not really required for them to be pressure boundaries. The ones that are required to be pressure boundaries are these two, the interface ones. So this maybe could be something else. Could be let's say velocity outlet. Where's or outflow. I'm just gonna put as an outflow, right? So that you can see what is happening. So the only pressure boundaries that I have is what appears here on the interface. Once you've done this, you come to the mixing planes, right? So on the mixing planes, you should be able to see both of these, right? So this one is pressure inlet, this one here is pressure outlet. Let me just save this. So my upstream, my then I select my upstream and my downstream zones. Make sure you select this properly. So this one is my upstream. This one is my downstream. Then I say create. Once I say create, it will create the mixing plane. So the data or the flow at these boundaries is mixing, right? I will explain in another video what all this means, what are the interpolation points and under relaxation factors and all these things. But for now, I'll just say create. When I say create, you see it has created the boundary, which is here, the interface zone, or the mixing plane. So the data, pressure data and all this flow data will be passing through this one, into this one, through this interface. and you then proceed with setting up all the boundaries the way you want to set up. If this is a pressure boundary, you have your pressure boundaries here, or velocity boundaries, and all those things. Remember what I said before, this you set up as periodic boundaries, this one, periodic boundaries, and there you go. Everything else will be the same. Once you've done the setups and you put in the physics and set up the physics, your model will run as if it's just solid one solid model. Thank you very much. I hope you enjoy it.